So in the last two sections, we're discussing about the quadric surfaces. So we have already discussed the ellipsoid and the elliptic paraboloid. In this section, let us discuss about the cone, the elliptic cone. So we know that what the equation of an elliptic cone is in the form x square by a square plus y square by b square is equal to z square by c square. So from this equation we are able to understand that it is symmetric. The elliptic cone is symmetric with x, y and z coordinate axis, and the only intercept that it has is on the origin. So let us consider the lines z is equal to plus or minus c by by. So this is possible only when x is equal to 0 and the line z is equal to plus or minus c by ax, and this is possible when y is equal to 0, and thirdly we are referring to the point 0 0 0, since we said that the only the only intercept that it had is with the origin, so we are going to take the point 0 0 0, which here we know that z is equal to 0. So now let us consider the section of the cut sections of a plane z is equal to z naught. So here we can see the xy plane. So the first half here we are able to see that the ellipse x square by a square plus y square by b square is equal to 1. This is in the plane z is equal to c. So here we are able to see that. So here this is a surface here of the ellipse which shows that x square by a square plus y square by b square is equal to 1. Then secondly we have the z is equal to, so this is a z is equal to c here, and here we can see the z-axis. At the same time, the A and B points are also being referred to as here. So the line z is equal to c by by, which is in the y-x plane. So this is the x plane and this is the y plane we have here. So here we are getting the lines z is equal to c by by, because we know that when it is z is equal to c by by here, x is equal to 0. So it lies in the y-z plane. Here when it comes, there is both the coordinates, so it is lies in the plane z is equal to c. So this is c. We can see that this cz is equal to c. In this plane the first ellipse lies, and we have the third line that is equal to c by ax, which is, we know that when z is equal to the line z is equal. So here are the lines which comes as a part of the ellipse, and first the ellipse is the total circle which we can see as a circumference of the upper layer which is being seen here. So the line z is equal to c by ax. So this lies in the xz plane. So here we know that the y is equal to 0. So when we join these lines, we are able to get an ellipse. So here we are able to understand that the sections cut by the plane z is equal to z naught, and below the xy plane are ellipses. So here z is equal to z naught and the xy plane. These are the cut centers of the ellipse, and whose centers lie in the x-axis and whose vertices lie in the lines. The two lines what we discussed, what are the two lines we discussed is z is equal to c by by, and also the line z is equal to plus or minus c by a. So if a is equal to b, so from this we are also able to conclude that if a is equal to b, then the cone is said to be the right circular cone. So I hope with this you are able to understand the cut section of the elliptic cone, the equation of the elliptic cone. So we had already discussed this. So just let us have a recap from the beginning. The equation, that is a square by a square is equal to y square by b square is equal to z square by c square. From there we are able to understand it is symmetric with all the three x, y and z plane, and the only intercept which lies is in the origin, and the two lines which is cut by the plane x is equal to z naught is in the xy plane is the two. These are the two lines which is that is z is equal to plus or minus c by by, and z is equal to plus or minus c by ax. So with this we are able to say that if a is equal to b, the cone is a right circular cone. Thank you.